Okay, let's just dive right into this. Welcome to this explainer, where we're going to unpack one of the absolute greatest mysteries left on planet Earth. We look up at the stars, we send rovers all the way to Mars, but we've got this massive, unsolved puzzle sitting right here at home. Today, we're exploring the deep ocean, and more specifically, figuring out exactly why so much of it remains completely unseen by human eyes.
The sheer irony of our scientific achievements is honestly kind of wild. What if I told you that we actually know way more about the surface of the moon than we do about our own oceans? It sounds totally crazy, right? But it's true. We have these incredibly detailed satellite maps of lunar craters hundreds of thousands of miles away, but when we look down into the waters of our own home planet, we are essentially flying blind.
And the data totally backs this up. 80 to 95%. That is the staggering number representing exactly how much of our ocean is still entirely unexplored. Think about that for a second. It's this massive, silent world that makes up the vast majority of our Earth, and yet, for the most part, we have absolutely no idea what's actually down there.
So the big question is, why? What is stopping us? I mean, we've got advanced AI, quantum computers, reusable rockets, the whole shebang. Why can't we just drop a camera down to the bottom of the sea and take a look around? Well, as we're about to find out, the logistical nightmares keeping us out of the water are actually some of the most extreme physical barriers in the known universe.
So let's start right at the top of Section 1, the surface, focusing on scale and the mapping challenge.
First up, we've got to talk about the scale. Oceans cover about 71% of Earth's surface. That is well over 2/3 of our entire planet. When we talk about ocean exploration, we aren't just talking about searching a dense forest or driving across a continent. We are talking about an area so breathtakingly massive that our human brains honestly struggle to even comprehend its true size.
To really put that into perspective for you, imagine trying to explore something that big with the vehicles and cameras we currently have. It is, quite literally, like trying to map every single grain of sand in the Sahara Desert. Even if we use the absolute best, most cutting-edge modern technology we have today, scientists estimate it would still take hundreds of years to fully explore everything underwater.
Now you might be thinking, well, hold on, why not just use satellites? We use them to map land all the time. And yeah, you're absolutely right. Satellites map dry land super easily, but the ocean throws a massive wrench into that whole plan. Water actually blocks most signals. Electromagnetic waves from our satellites just bounce right off the surface or get instantly absorbed. So instead of snapping a nice, clear picture from space, scientists are forced to use sonar, which relies on bouncing sound waves off the ocean floor.
But here's the catch. Relying on sonar builds a massive roadblock. The reality is incredibly tedious. First off, it's slow. Second, it's way less detailed than taking optical images. And third, and probably most importantly, it requires ships to physically travel across the ocean's surface, literally going back and forth dragging equipment. You can't just scan it from orbit. You have to manually sail over it. And that is exactly why large swaths of the ocean are still only roughly mapped, lacking any real detail.
All right, so that's the surface. Now let's move on to Section 2, the dive, descending into the hostile deep.
Let's imagine we finally find a cool spot we want to explore, and we begin our descent. The environment is about to change, and I mean drastically. Sunlight can only pierce the water for a very, very short distance. At exactly 200 meters, which is about 656 feet down, the light just taps out. The energy from the sun simply cannot penetrate any further through the density of that water. This is a huge critical threshold. Below that 200-meter mark, total absolute darkness. No light, zero visibility whatsoever. It's essentially like exploring an endless, pitch-black cave where your flashlight barely even works. This complete sensory deprivation is what makes the deep ocean so incredibly hostile. Without light, it's exceptionally hard to see anything clearly. Taking photos or videos of your surroundings becomes a massive headache, and just navigating safely turns into a highly dangerous guessing game.
And believe it or not, the darkness isn't even the only problem. The deeper you go, the colder it gets, eventually plunging to near-freezing temperatures. This sets off what scientists call a cold chain reaction. That freezing environment causes vital electronics to just fail. Batteries, which, by the way, run everything from your lights to your life support, drain significantly faster in the cold. Even the materials building the submersibles become dangerously brittle. When you combine that freezing cold with the pitch black, even our most advanced robots really struggle to survive down there for very long.
But honestly, the darkness and the cold totally pale in comparison to the real monster of the deep: pressure.
In places like the Mariana Trench, the absolute deepest part of our oceans, the pressure from the millions of gallons of water sitting above you is over 1,000 times stronger than what we feel up here on land.
To help you really conceptualize that, imagine having 50 jumbo jets pressing down on your body all at the exact same time. It is literally crushing. That monster pressure is exactly why we can't just send regular equipment down there. It instantly destroys anything that isn't specially designed with incredibly heavy, thick, super durable materials.
Which brings us right into Section 3, the logistics and the billion-dollar price tag.
Overcoming total darkness, near-freezing temperatures, and the weight of 50 jumbo jets? Yeah, that doesn't happen with off-the-shelf technology. To safely put eyes on the deep ocean floor, you need a massive checklist of specialized, heavy-duty equipment. We're talking custom-built submarines with specialized titanium hulls, highly advanced remote-operated robots, and massive surface research ships just to deploy them. And the cost? It ranges anywhere from millions to billions of dollars. Exploring the deep ocean is fundamentally not a cheap hobby.
Because of that astronomical cost, organizations like NOAA and NASA can only really afford to explore incredibly small parts of the ocean at a time. The tough reality of government budgets is that funding is a zero-sum game. Governments often have to prioritize high-visibility projects, like space exploration, or urgent needs like surface-level climate research and other projects. And unfortunately, that leaves deep-sea exploration severely underfunded by comparison.
But let's look at the bright side as we hit our final part, Section 4, the abyss and the mysteries waiting below.
Because despite the massive scale, the total darkness, the crushing pressure, and that hefty price tag, the payoff for pushing through all these barriers is nothing short of breathtaking. Every single time we manage to explore a little deeper, we find something astonishingly new. We discover these strange, glowing creatures that literally create their own light in the dark. We find entirely unknown species that totally challenge our understanding of biology. We map massive underwater volcanoes, and we stumble upon entirely self-sustaining ecosystems thriving in conditions that we previously thought were completely dead. It is quite literally like discovering a brand new world, right here on our own planet. So the main takeaway you should have from this explainer today is this. Humanity didn't just ignore the ocean. We didn't forget about it. It's just incredibly massive, dark, dangerous, and insanely expensive to navigate.
But that difficulty? That means something incredibly exciting for our future. There are still vast, uncharted mysteries on Earth, just waiting to be discovered. Maybe the next monumental scientific breakthrough isn't waiting for us in the vacuum of space. Maybe, just maybe, it's hidden deep beneath the waves. So, I'll leave you with this final thought. If we have explored a maximum of 20% of our oceans, what do you think is still hiding down there in the dark? Thanks so much for joining me on this explainer, and keep questioning the world around you.